Number 9 in the homework starts with classifying a curve. What kind, limnescate or limousin or whatever. Determine the symmetry, find the maximum R values, find the zeros, and then sketch it. So we've got quite a lot to do for each of these. So we start out with the type of curve. So we have R squared equals 49 sine 2 theta. So that is a limnescate. And because it's got the R squared and A sine theta. Okay, and it will have, we know these are symmetric to the pole if it's a sine. So I already know that it's limnescate and it's symmetric to the pole. All right, so we're going to go with, there's my symmetry. We're going to find the maximum R values. So here I go. I say the absolute value is R, and I have to solve for the square root. So this is the square root of 49 sine theta. So I'll put -1 in for first, and I get a negative, so that's a DNE. If I put square root of 49 times 1, I get 7, the absolute value of 7. So I know that my largest number, R, will be 7. And where is it 7? I put 7 in for R, and I get 49 is 49 sine 2 pi, 2 theta, not 2 pi. So sine theta is 1. Sine 2 theta is 1. Well, where is sine 1? Sine is 1 at pi over 2. And now, because it's 2 theta, I have to go to 4 pi. So I would go to 5 pi over 2 also. And so I get, dividing now by 2, pi over 2 becomes pi over 4, and 5 pi over 2 becomes 5 pi over 4. So the maximum values occur of 7 occur at pi over 4 and 5 pi over 4. So, okay, so we'll remember that. And now find the zeros. I'm over here. Set 0 equal to R equal to 0, and we get sine 2 theta is 0. Where is sine 0? Sine 0 at 0, pi, but we have to keep going. 2 pi, 3 pi, we don't really need 4 pi because it's up to 4 pi. And then we divide each of those by 2 because we have an angle that's 2 theta. So it gets to be theta. It gets to be 0, pi over 2, pi, and 3 pi over 2. All right, so we have our zeros and where those occur. And that gives us a bunch of points to work with. And so now we plot. We start with theta on the left, and then R is the square root, and it would be plus or minus. So guess what? Because of this plus or minus, we're going to get the polar symmetry, okay? So you'll see. So 0, we figured out, was going to be a 0. It's one of these zeros down here, so 0, 0. And remember, when it's petals, we know this is a limnescate, so it's going to have like petals. We want to use the 12s probably. So I used pi over 12, and sticking that into this equation, I got plus or minus 5. So first 0, 0, I'm going to graph in green, and then at pi over 12, it's plus or minus 5. So there's the plus 5 at pi over 12, and then going backwards, there's the minus. And see how you're getting the polar symmetry right there, the symmetry against the pole? Going to pi over 6, it's about 6.5. So there's my pi over 6 point, and it's also negative, so that would give me the second one on the other side of the pole. Pi over 4 gives you 7, and that's one of your maximums, right? Down here, 7. Pi over 4 happens. And so going negative 7 from pi over 4 gives you the point over there. Pi over 3 back to 6.5. So I have a point here, and negative 6.5 would be down here. And then at 5 pi over 12, this point here, it's positive 5 and then negative 5. So that would be over there. And so we end up, now at pi over 2, we're back down to 0. All right, and because of symmetry, we know we're done. It's a limnescate, and we've got it graphed. So that was number 9. All right, and moving on to the next video for number 10.